Okay, we're moving along with 4.4 here. What we can do is summarize the labs that you just had finished, characteristics of quadratics. So we know that if this has a +2, what happens is that the quadratic shifts 2 places upwards. Okay, so the way we redraw that one is the same width, except the vertex now is going to pass through 2, like so. And the same thing here, when the a value is positive and it's a -3, parabola is going to be about the same width, but the vertex is going to pass through -3. Okay. So that's news, old news for you guys. What about when you change the values in x minus p? Pop that into your calculator, and what happens there is opposites, right? So if this shows -2, it represents a shift of 2 to the right. Try to make it the same width. And a +3 is actually a shift of -3. Well, shift of 3 to the left. Okay. So those are the shifts that occur from the lab that you saw from before. What about changing the a value? Well, the a value has 2 things. If the a is greater than 1, we see that the parabola, what happens there is that it skinnies up, it gets a little bit thinner. Rate of change is faster. If the a value is less than 1, the parabola gets wider. If you put a negative sign in front of it, it just flips it. So -2 would be a thinner than a standard parabola, but now it's facing downwards. And the same thing with a -0.5. It'll be wider than the standard parabola, but that's also facing downwards as well. Okay. Okay, we're going to look at a new form for quadratics today. This is one that is in standard form. Now, in standard form, the nice thing about standard form, it gives you enough information so that you can actually graph this quadratic. So this is what standard form looks like. Y is equal to the a value. That's how wide the parabola is. X minus p. P is the x value of the vertex plus q. Q is the y value of the vertex. And so determine the equation from this quadratic function. Okay, so we're going to determine what the vertex is here. Looks like 4, -2 works okay. And then we'll just pop that into this equation. So y is going to be equal to a x minus 4 squared minus 2. And then you choose a point on the parabola for the x and the y. So this just happens to be 2, -14. So I'm just going to plug in 2, -14. So you're trying to pick clean points off this. -14 is going to be equal to 2 minus 4 squared minus 2. Okay, we'll just add 2 to both sides here, and we get, this turns out to be 4c, and divide both sides by, sorry, that should be a, divide both sides by 4, so my a value is going to be equal to -3. Once we know the a value and the values of the vertex, then we can write the equation. So y is going to be equal to -3 x minus 4 squared minus 2. Okay. Turn to page 118. Try the check. If you struggle with this, the full solution is in your work text. So pause the video and try the check. Okay, so we're going to go on to the next one. Example 2, quadratic function for standard form. What information can you grab from this? Okay, so the first thing we're going to do here is take a look at our a value. And in our a value here, what happens is we see that it's positive. There's +1/4, so we know that it's going to be opening upwards. The vertex we pull from here, so it's going to be at 3, 1. So we put that inside brackets. Equation of the axis of symmetry, that's simple. It's a vertical line, so you always set it through the x value of the vertex. The intercepts, okay, let's do the x-intercepts. On the x-intercepts, the y value is going to be equal to 0. So here 0 is equal to 1/4 x minus 3 squared plus 1. And then what we'll do is multiply both sides by 4 and put the x minus 3 on the other side. X minus 3 squared equals -4. Oh, problem. Can't have the square root of a negative number. So there's no x ints. Because you can see it here. It starts at 3, 1 and goes up. So it starts above the x-axis. Where's the y-intercept at? So with the y-intercept, x equals 0. So we've got y is equal to 1/4 0 minus 3 squared plus 1. Pop that in your calculator, and the y-intercept becomes 3.25. This last part here that you can't see is the domain and the range, but I'll squeeze it in here. So the domain is usually the same for the parabolas we're studying except for word problems. X is included instead of real numbers, so they're all numbers for the X. For the range, we take a look at the vertex. It goes up, bottoms out at 1, so X has to be greater than or equal to 1. Okay, sorry about that. You guys try the check on this one. Oh, sketch the graph. Okay, so what we'll do here is we'll pop in a plane and pop in a plane here. So we'll just put it here, here, and oh yeah, need a little bit of fixing up here, so that's going to straighten up. I should use a ruler, I guess. X here, Y here. We know that the vertex is at 3, 2. Sorry, 3, 1, and it moves upwards. So we go 3, 1 here, and because the a value is a quarter, it's going to be a little bit wider than the standard parabola. This is just a sketch. We're not looking for it to be exactly accurate. Okay. All right. Try the check on your own. Pause the video and check with the answers inside your work text. Okay, we are moving on to example 3. Determining the equation of a quadratic through its characteristics. So here you have x equals 3. So we know the x value of the vertex is at 3, and we also have 2 points. So we're going to go through a process to figure out what the equation of this parabola is. So here we have one line, right? At least we can do this. Y is equal to a times x minus 3 squared plus q. Okay, now we can use point C. So from here we'll plug in the values for point C for x and y. Negative 1, negative 6. Okay, so y is going to be equal to negative 6 equals a. What's the x value? Negative 1, negative 3 squared plus q. Okay, and figure out here. So negative 6 is equal to 16a plus q. The main idea behind this first line is to get the q isolated. Okay, because what's going to happen in the second line is we're going to use point D, which we get from the question that's at 5, 0. Okay, so we'll put in the second line. 0 is going to be equal to a times 5 minus 3 squared plus q. We're going to try and solve for q. So 0 is going to be equal to 4a plus q. So negative 4a equals q. Let's call that line 2. Okay. Now, what we're going to do is we're going to substitute 2 into 1. So this is from IAPC in grade 10. So we end up with negative 6 equals 16a, and this is where we put in the minus 4a. We're substituting in for the q. So we get negative 6 equals 12a. So my a value is equal to negative 1/2. Okay, so we'll put a into 2 to figure out what q is. So 0 equals 4 times 1/2 plus q. So my q is going to be equal to, that's negative 1/2. So q is equal to positive 2. So here's my final equation. A equals negative 1/2 x minus 3 squared plus 2. Okay. You can look at this again because there's a lot of math in it. Try to check, see how that works for you. And we'll go on to the final example, which are the word problems. Okay, for these ones I recommend that you draw a picture for sure because there's a little bit of a problem here. So a cable that supports a bridge is parabolic. Okay, so there's the cable here. The horizontal distance between the ends of the cable is 140 meters. Okay, so we'll put the 140 here and here. And the midpoint of the cable is 14 meters below. So what if we made the vertex of the parabola here and put that in a Cartesian plane? So that's at 0, 0. Okay, so we know that this distance here is 14 meters. Okay, so sometimes the diagram helps with this. We'll call this point here 0, 0. And we can just use this equation. Y is equal to ax squared plus bx plus c because these are at zeros. So we know that this is going to be at 70 minus 40 sorry. It's the dog telling me that we're out of time. So I'll do this really quickly. My a is equal to 1 over 350. So the equation y is equal to 1 over 350 x squared. Okay, try the check. And after the check, you can try this assignment.